consisting of two, so it is the repulsion of electron. This this the VSEPR is we have to draw in order to predict the shapes of molecules. Okay, this is only prediction of the molecules. Is the molecules that we know, like carbon dioxide, is it to be like that or not? We are not able to see because they have their own interaction, and the interaction is not visible to our bare eyes. Okay, and then in the VSEPR, the arrangement, of course, minimize the repulsion. Why is it like that? Because there is a VSEPR stands for the R is repulsion. So there is a repulsion between the electrons. What are the electrons that repel? Is the Yesterday we learned already about lone pair and then also bone pair. One X, one dot
Hello.
is called a bone pair, and then XX is called a lone pair, or dot is a lone pair. Okay. To predict the shape, we have to draw dot and cross diagrams. And then in order to measure the angle, in this one, the angle is not measured using a protractor. Okay, so protractor will fail in this one. Why? Because not everyone is able to draw 3D diagram. We only maximum can draw in general. The drawing skill is maybe up to two-dimensional, not 3D. Okay, so the angle measurement, the greatest is by lone pairs. Lone pairs means lone pairs and lone pair will repel the greatest. And then the medium is lone pair, bone pair. And then the smallest is bone pair, bone pair. That is how to predict the shape. And then next. And then this one, let's see the VSEPR with no lone pairs. VSEPR with no lone pairs, it is written on your textbook also, page 5. But this one, in my presentation, I give the size of the angle. So if two bone pairs, the shape is linear. We cannot write the shape is straight line, because line is line a shape? I don't think line is a shape. So it is linear shape, meaning is straight line. And then if this one for this presentation, this slide specific, if it is written with no lone pair, so there is no lone pair at all. Two bone pair, angle 180, the shape is linear. What is the example? Example is uh, example is BeF2. You can imagine BeF2, we have to see the central atom. The central atom Be, there Pe has 2 electrons in the outermost shell. So all these 2 occupied by F. So there is no lone pair. The other example of 2 bond pair with no lone pair is carbon dioxide. You draw on your paper carbon dioxide, the dot and cross diagram of carbon dioxide. Carbon on the right hand side has double bond, make a double bond with oxygen. On the left hand side, the carbon makes a double bond. This lone pair is specific, different, the diagram from BeF2. What makes it different? Because there is a double bond. Many students consider that in CO2 there are 4 bond pairs with no lone pair. Some of them write it tetrahedral, but it is incorrect. It is linear. Why? Because later on in this period, we are going to study also about the overlapping orbitals. And then 3 bond pairs with no lone pair. Example, in C2H4, ethene. So it is divided by 2. On the right hand side, C double bond and then H2. So it forms trigonal planar. And then the bond pair for CH4. The shape is tetrahedral, angle 109.5. In A level, we need to learn by heart this shape, angle, and number of bond pair, number of lone pairs. Okay, and then five bond pairs without lone pair is called as triangular bipyramidal or called as trigonal bipyramidal. Okay, on page 60 is written the drawn also the shape of the molecule. It is quite difficult for me, especially for me to draw the shape. Why? Because it requires a high skill of drawing to draw the 3D. And then next, the six, if there are 6 bond pair with no lone pair, example, sulfur hexafluoride. The shape is octahedral, angle 90. Number 5, 5 bond pair with no lone pair. It is 90 and 120. It is not odd. 90 and 120. Where how do scientists measure? It is not our concern how they measure it. Of course, what I know, we have to learn it by heart. Okay, and then this one VSEPR with 1 lone pairs. With 1 lone pairs, okay, with 1 lone pair, it is with 1 lone pair, it is there are 2 bond pair, 1 lone pair, The angle is 119, V shape or bent. The example is nitrate ion, not nitrate, it is nitrate ion. And then uh, three bone pair with one lone pair. The shape is trigonal pyramidal. Trigonal pyramidal is belongs to NH3. If you imagine your after you draw NH3, there is a lone pair in the end. One lone pair and then three bone pairs. And then four bone pair with one lone pair. It is the shape is seesaw. The molecule is SF4. S has 6 electrons in the outermost shell. So these 4 electrons in the outermost shell of S make covalent bond with the 4 fluorine. That produce the leftover is one lone pair. And then 5 bone pair with one lone pair is called square pyramidal. Okay, square pyramidal, it is IF5, not L, it is I. U2 iodine fluoride. Okay, iodine pentafluoride. And then next, this one with two lone pair, two bone pairs, and two lone pairs. Example of the molecule is water. Water, when we draw dot and cross diagram of water, there is two lone pairs. Two lone pairs in the central atom oxygen. Then, so we know that lone pairs and lone pairs will repel the most because of the repulsion of the lone pairs that make the bond angle to be 104.5. So with the previous one, with this one, oh sorry, with this one, 119 V shape, and then 104.5 also V shape. So what does it mean in here? A level wants us to learn by heart the V shape for specific molecule is 104.5. How do we know what specific molecule? We have to draw dot and cross diagrams. We have to tell how many bone pairs and how many lone pairs. Okay, so for 3 bone pairs and 2 lone pairs, the angle is 90, T-shape. The example of the molecule is iodine chloride. And then for for bone pairs, for bone pairs, uh, the angle is 90. So 4 is square planar. The molecule, it is the polyatomic ion ICl4 negative, and then the bond angle is 90. So it is the same T shape, the same angle, but different shape. One is T shape, one is square planar. How does the square planar look like? square panel look like is a bit difficult to draw. Square panel is like a pyramid, square based. Square panel is like a parallelogram. Okay, and then next this one. The last is VSEPR with three lone pairs. Three lone pairs. There are two bone pair with three lone pairs. Two bone pair with three lone pairs. The shape is linear. So the example of the molecule is I3 negative. What does it mean in here? It means that uh, when a question give us the what is that the molecule, we have to draw dot and cross diagram. After drawing dot and cross diagram, and then we have to able to tell how many lone pairs, how many bone pairs. After we know how many lone pair and how many bone pairs, then we can tell what is the shape and what is the size of the angle. Okay, and then there is also electronegativity. Okay, electronegativity here is the uh, is on our textbook. So I explain this one, electronegativity, page 62. Okay, electronegativity is the from left to the right, electronegativity of the elements increase. We learned already in chapter 2 the property of the from the atom. From left to the right, the electronegativity increases. From top to the bottom, the electronegativity decreases. Okay, so from left to the right increases, from top to the bottom decreases. Electronegativity is the ability of an atom to take electron, or it has an unequal sharing. Look at this one, this molecule. Cl and Cl considered to be non-polar because they have the same electronegativity. Cl is electronegative and the other Cl also same electronegative. So they have the same, so they are considered to be non-polar. And then HCl, hydrogen is positive ion. That's why it is drawn in here is smaller circle than the Cl. Cl is negative. It gains an electron. The electronegativity is not the same. Different. There is a difference in the electronegativity. That makes this one HCl is polar. And then do we need to know the value of the electronegativity? In A level, we do not need to know. Why? Because we know the trend from left to the right. And then in ionic bonding, it is very obvious electrons are being transferred. If electron is being transferred, So the electronegativity is huge. The electronegativity is huge that makes all the ionic compound able to dissolve in water, because water itself is polar. If polar means there is a difference in electronegativity. Okay, and then uh, so this is electronegativity. Okay, the last, this one. Next, dipoles of a molecule. So in here, I already tell the bond polarity, which one is polar, which one is non-polar. Do we need to know the electronegativity? No. And on the textbook is written, page 63, written the value of the electronegativity. But we know that from left to the right, increase, from top to the down, decreases. That's it. If there is a difference in the electronegativity, then it is polar. If there is no difference, then it is called non-polar. Okay, and then now dipoles of a molecule. Dipole of a molecule, it is we are determining the polarity. We know from this one, this is the structure of formaldehyde. Formaldehyde is HCOH, or called as methanoic acid. Oh, sorry, it's not methanoic acid. It is aldehyde. It is methanol. Okay, it is methanol. Oxygen is very electronegative compared to carbon. Carbon is slightly electronegative than hydrogen, because this one, uh, the difference in the electronegativity, so we have to draw like the symbol D. This is the D stands for dipole. This is dipole negative, this is dipole positive. So there is a increase in polarity that makes this aldehyde able to dissolve in water. And then, so there is this one. This is called as dipole moment. Dipole moment is the positive carbon and then negative oxygen. Okay, and then there is this one, overlap orbitals. Overlap orbitals on our textbook. Overlap orbitals on our textbook is uh, this one. Uh, Overlap orbitals is to explain the page 66. Okay, so the rest, for the rest of the subtopic, you have to read from the textbook. Okay, so in here I explain already this one, and then the overlap of orbitals. This is forming the sigma and pi bonds. From page 63, s orbital, sigma bond, sigma bond and pi bond. Sigma as represent the s orbital. So overlap of s orbital is called as sigma bond. And then overlap between the s orbital and p orbital, this is also called as sigma bond. And then the overlap between p orbital and the other p orbital is called as pi bond. Okay, this is the pi bond. Okay, look at page 66, figure 3.35. There is a figure explaining to us the single bond or sigma bond. Okay, this is correspond to the s orbital overlapping. This is called as sigma. And then there is a p orbital. What happens when p orbital occur? P orbital, when p orbital overlap, it will form a double bond. So single bond here. This is called as s orbital overlapping or sigma bond. This one, the blue one, is called as pi bond. How come there are two pi bond? It does not have two pi bond. It has only one pi bond. Why the diagram 2? We have to remember that in p orbital there is ph, py, and pz. And then the shape of p orbital is loops, dumbbell. So two loops. So this one, two loops. One loop is at the top and the other loop is at the bottom. So this one is called as the two loops. Okay, this is the overlap orbital. For the homework today, I already attached on your Google Classroom that you have to draw dot and cross diagram of different molecule or different compounds. Okay, until here, is there any question? Is there any question?
Is it the usual cross and dot diagram?
I am just confused.
Yes, Natasha.
Is it the one that is it the one that we usually draw like just like two elements maybe and then the usual cross and dot diagram?
Yes, the basic of this VSEPR is the usual dot and cross diagram that you learned already in grade 9.
Oh, okay. Thank you, teacher.
Yeah. Nathan V, what was uh, what was your problem?
I'm just a bit confused about everything actually. So, I
Ah,
mean, like literally. So I need to see this more. I mean, like need to see this more. So I see there is some kind of an overlap orbitals.
yeah.
So why is it like this? Actually? Why orbitals can overlap?
Why orbitals can overlap? Because they make bonding. You know,
So
you learn in covalent. What is covalent bonding? Is it sharing or transferring?
it's sharing in coconut.
Sharing. Sharing in this one is called overlap. You have five, five marbles. I have five marbles. We share. Sharing. means your marble and my marbles are overlapping. So in total, how many marbles you have? 10. I have 10 also, right? So it means sharing. So you have 5 and I have 5. This is combined together. So finally, you have you can people can say that you have 10 and I also have 10, but individually we do not have 10, we have only 5, but we are overlapping the marbles represent the electrons. So what is being overlapped here? Electrons. How it is drawn like this? um, Nathan V, let me ask, how does electron move in an atom?
Electrons will move by changing the shell. I mean, basically the way that I see
How does the
electrons
shell
moving.
look like?
The shell is 3D, so basically it's like there's shell number one in there, shell number two going out of shell number three
Yeah,
going
how does the shell look like? Is it like a circular or is it like a box?
spherical, sir. Spherical.
Circle. If circular, then but the circular is it circle perfect circle or in orbit? It
In
is
orbit,
it
sir.
is in orbit. In orbit, if we look from far, from side view, it looks like an oval. Am I right?
Mm.
So this is the overlapping of the electron movement. The electron move. How fast does an electron move, Nathan V?
The electrons move extremely fast, I must say.
Exactly. If something move very fast, we can draw only path, the path, the path. It moves like a circle, move like a
Ah,
oval. Can we see
okay.
the electron? Cannot, because the electron move very fast. If the electron move very slow, then we can see everything. We can see the electrons in the air. But since electron move very fast, we are not able to see it. Okay. Any more question?
Nah, I don't think so. Just the question is unrelated actually. Related a bit, but it's out of curiosity, I would like to ask about basically how
Your question, Nathan V, is requires imagination to answer it, because we need to imagine how does the electron move and how fast they move.
ah okay sir.
Okay,
I think that is for now.
yeah, your question might clarify others' doubt. Okay, next, another question. Please, if not clear, please ask right now. Do not wait until everything is done and then in the last you told me that you do not understand since the beginning. Then if you do not understand from the beginning, why don't you ask once we started?
Teacher, I honestly don't understand with the angle and then the shape thing.
Angle and shape thing, as I told, you have to draw dot and cross diagram. Okay, you have to draw dot and cross diagram. It is not necessary for us to draw the 3D, three-dimensional shape. Okay, we do not need, it's not necessary for us to draw the 3D shape. And the angle we do not measure with a protractor. We have to learn it by heart.
And memorize all the angle and the shape.
Exactly. That's if you want to make it emphasize strongly, yes, we have to memorize. We have to memorize.
And did you give one example when teacher said we have to draw the cos and dot diagram with the angle and the shape?
Okay, angle and shape. You can open your textbook. Okay, open your textbook. Your textbook page. Uh, page. Let me see this one. Let me see the this one. Page 62 of the e-textbook. Page 62. Figure 3.24. Shapes for XEF2, CLF3, and SF4. Have you opened it?
Yes, teacher. Yes, teacher.
Yeah. You see the figure 3.24?
Yes.
Okay. In XEF2, it is drawn. There is a dotted line forming a triangle, right? And then there are dots that being made into loop. What are those represent? Lone pairs. And then F, XE goes to F is a bone pair. And then XE goes to another F, which is down, is also a bone pair. So there are two bone pairs with three lone pairs. And then there is also two lone pairs with three bone pairs. And then there is also one lone pair for bone pairs. How do we draw the shape? It is not necessary for us to draw the shape. We have to tell the shape and the angle. That's it. Okay. When you draw dot and
So
cross.
usually, yes, teacher. So usually we just in the question it's given the diagram and we just have to state the angle and shape.
Yes. Question is asking for what is the size of the angle and the shape of the molecule. That's it. If drawing as I know from the first A level, I taught in A level in 2010, 2011 until now, they do not give seesaw structure. They do not give trigonal bipyramidal. They give only simple one like linear, draw linear, and then draw bend, draw octahedral. Only like that, but not the difficult. If memorizing, yeah, they will ask what is the bone angle and the shape, but not drawing. Okay, so do not imagine beyond than that. It will make you confused because you confuse in the concept of how to draw. Okay,
So
Natasha.
if they ask you draw the like octahedral, do you draw it exactly as shown from the book?
Which one?
Well, they ask you draw the linear. We draw it like exactly like from the book.
Linear is straight line. That's it. Linear is straight
Uh,
line.
do we have to draw the middle dot and then the four electrons?
Yeah, the middle one represents the central atom.
Uh,
Yeah, we have to draw the dot to represent the central atom. Okay, do not imagine more than that. Do not try to make things complicated. In which I do not ask you to draw such a 3D, just such a having high drawing skill. No, just tell tell what is the shape, tell what is the bone angle. Okay,
okay,
because
thank you, teacher.
yeah, this give us the concept. Oh, this is bone angle, this is this VSEPR, and then this one also will give us also to tell us, oh, this from the drawing from the VSEPR we know that whether this molecule is polar or non-polar. Okay, let me go back to the previous presentation. Now, this one, Natasha, you see the dipoles of a molecule on that I share on the screen.
Yes, teacher.
What is the shape? What is the shape? What is the bond angle of this formaldehyde? What is the shape?
Um, I don't know, teacher.
Yeah?
I don't know.
No. How come you do not know? You should be able to draw dot and cross diagram very fast for this formaldehyde. Okay. Let me ask to oh wait. Let me ask to Bavia. Hello Bavia.
Yes, teacher.
Yeah. What is the bond angle and the shape of the molecule for formaldehyde?
Teacher, do we have to draw the electronic configuration first?
No need. Just draw dot and cross diagram.
Just a minute, teacher.
Yes. Okay. Let me check with Felicia. Felicia, have you drawn dot and
I'm
cross
still
diagram?
trying it, teacher. Still trying it, teacher.
Yeah. So, what is the this one? The angle.
3 lone pairs.
3 bond pairs. How many lone pairs?
Oh wait, sorry teacher. The bond is the one that is a combination of dot and cross.
Yes. We count the bond angle. We count the lone pairs and bond pairs from the central atom. Okay. What is the central here?
Carbon.
Exactly. How many lone pairs?
Is it two, teacher?
0.
Yes.
Teacher, the lone pairs for carbon or
Lone,
anyone?
the central atom. What is the central atom? Felicia already told us carbon. So how many lone pairs?
Zero.
0. How many
Yes.
bond pairs?
4.
Three.
3 or 4?
Uh,
Three.
If we answer 3 bond pairs, it is not correct. It is 4
4.
bond pairs. But this one, the double bond is overlap between s orbital and p orbital of the same element, of the same atom. So this double bond looks like one bond pair. Okay, so the shape of this is trigonal planar or triangular planar. And then we have to refer to the this one 120 degree. Okay, so the angle is 120. Number of bond pairs 3. It looks that it looks as if it has 3, but there are 4 bond pairs. How come? Because there is a double bond. Double bond is occurring uh, when an s orbital overlap with the other s orbital, and then there is a p orbital of the same atom overlap with p orbital. So that makes this double bond can be called as one bond pair. Okay. Tomorrow we are going to have exercise for this. After you draw dot and cross diagram, then we will have exercise for VSEPR. Okay. Uh, Now is your lunch time. Good afternoon, students, and thank you. We will discuss again.
So what is the homework there?
Yeah,
What is the homework for today?
dot and cross diagram. It's
Draw which one?
I already attached on your Google Classroom.
Okay, thank you.
Yes,
Thank you, teacher.
Thank you,
yes,
teacher.
yes. You're
Thank you,
welcome.
teacher.
Yes,
Thank
you're
you,
welcome.
teacher.
Thank you, teacher.
Yes.